Hello everyone, this is Neve from Edureka and welcome to this Raspberry Pi tutorial session. Now this session is going to be slightly long in comparison to most tutorial sessions that you see out there on YouTube, but this will give you a complete understanding as well as an in detail with respect to Raspberry Pi 3. Now looking at the agenda for today, we'll talk about what is Raspberry Pi and the various hardware configuration of Raspberry Pi which has changed over the years. We'll also be comparing them with respect to the different models that has come out. After that, we'll be looking at how to install an operating system on Raspberry Pi, and then we'll be looking at a tutorial using one of the major additional components to Raspberry Pi, which is Sensat. Following which, at the end of the session, we will be looking at a demo using Raspberry Pi, which is going to be a motion detection camera. Now, in our Sensat tutorial section as well, we'll be looking at 5 different demos, thereby giving you a complete understanding as well as a good learning experience from this session. Now, I hope you guys are definitely interested for this session. Let's move forward to the first topic, which is basically the need for Raspberry Pi. Now, Raspberry Pi today has become so common that you can find it across most households as well. Today, it has become one of the most cheapest and common computing device that can be found almost everywhere. But let's actually go back to understand the ideology which brought Raspberry Pi into development itself. Now, Raspberry Pi basically was bought by the Raspberry Pi Foundation to introduce or to bring in the information technology back to the schools wherein students can learn how to program from scratch. The growth of technology today has grown to such a level that everyone today has ease of access to do anything on a computer. But back in the early and late 90s and 2000s, for using a computer, you needed to know how to program and how to work around with respect to it. So this in turn helped to build a very strong foundation for programming knowledge. And with the growth of UI, everything has become so easy that today you don't need to learn programming to do much. But at the same time, this has made it harder for people to identify and understand good programmers from those who are not. So in order to build a generation which starts with a very strong programming foundation and fundamentals, the main ideology was to introduce or take back IT to the basics and make it accessible across every school as well. Now, again, as I said, it was introduced by the Raspberry Pi Foundation in 2012 as such. Now, moving forward, what exactly is Raspberry Pi? Now, this is one of the questions most of you would have across your mind as well, because you might have heard about Raspberry Pi, but you might still not have a clarity. So let me help you clarify that right away. Now, as per the definition, Raspberry Pi basically is a series of various small single board computers which actually have additional features as Bluetooth, Wi-Fi, USB capabilities, general input output ports, and so forth. Now, it basically is a very small, low cost credit card computer which actually can be plugged into any monitor, as well as you can include a keyboard and mouse, and it increases the opportunity for people to explore, learn, and understand how to program as well. Now, Raspberry Pi basically is a combination of Raspberry operating system and Pi, which basically stands for Python programming language. Moving on, some of the capabilities that Raspberry Pi enables you to do is that it helps you to browse the internet as well as watch complete HD videos on the same device as well. So all you need to have is a HD supported display as such. Now, apart from that, even basic operations like making spreadsheets, creating words, presentations, all these can be done on Raspberry Pi. And you have a huge set of games that are available which can be played on Raspberry Pi, making it quite interesting and easy as well for people to enjoy the component as well. Then you have various add-on capabilities like infrared cameras and security system which can be built keeping Raspberry Pi as the core hardware as well. Then you can also use music machines as well as detection of weather stations. Now these are just some of the top capabilities that I have picked up from the list. Raspberry Pi today has become one of the biggest components that has enabled users to achieve and create a lot as well. Today, the capability of Raspberry Pi is restricted just to your imagination. Whatever you can imagine can be done using Raspberry Pi given the amount of effort put into that. Now moving on, let's look at the Raspberry Pi hardware as well. Before that, let me show you I would be using a Raspberry Pi as part of this tutorial session. So let me just give you a simple overview of the component as such. Now what you're basically seeing is that the Raspberry Pi hardware. So let me just switch over the camera and let me show you the Raspberry Pi. Now Here what you're seeing is the Raspberry Pi 3 hardware as such, and this is your processor and system on chip, which is an Adreno A53 processor. Now, two important ports here is the CSI port, which is the camera serial interface, wherein you can connect camera directly to the Raspberry Pi, and the DSI port, which is the display serial input port. Okay, now let me just flip this over slightly. And if you see, this is a 2.5 mm micro USB connector. So your standard mobile charger can be used to charge the Raspberry Pi. And this is a standard HDMI port for display. So your standard TVs and monitors which have an HDMI support can be used to become a video interface for that. Then you have an audio jack which is used to connect your audio inputs. Now let me just flip this slightly over and let me just zoom out a bit. Now, if you see, we have an Ethernet connector, following which there are 4 USB slots as well. So when you see here, there's a 40 pin general input output pin present here. So this is something that's quite interesting and configurable from your Raspberry Pi software, where you can configure for what each purpose pins can be used, which we'll be seeing a little ahead. Now the final thing that I want to show you is behind here. When you flip backside, so there is a micro USB slot present here. This is mainly to insert your memory card, and when I say memory card, I would generally recommend at least a 16 GB memory card. This is mainly because the operating system in itself is about 4 GB, and if you use an 8 GB, then what happens is there's very less storage space for your operating system to work on as well. So a 16 GB memory card would be really helpful. And one thing that you want to see is this is an Evo class, which is something similar to a class 10 memory card. So if you're getting a memory card, make sure it's at least a class 8 or class 10 memory card so that you can have high disk read and write processing. Now coming back. Now moving ahead, let's just skim through the various changes that has happened over the hardware of Raspberry Pi. Now we are not going to devote too much time into this because this is a completely in detail session. However, I would be stopping at these slides for 10 seconds. So if you wish to know more, you can pause the video and get a complete look as well. Now, talking about the processor, the first generation of Raspberry Pi initially came with a Broadcom BCM2835 SoC, and it basically was similar to the first generation smartphone chips. And the architecture that was used also was an ARM v6 architecture. Now, over the years, Raspberry Pi 3 has grown a lot, and today it has a capability of 1.2 gigahertz, which basically is because of the ARM Cortex A53 64-bit processor, and is considered to be 10 times faster in comparison to Raspberry Pi 1. Now, talking about the change in Raspberry Pi over the years, as you can see here, the various models have been listed, and the architecture change has also been mentioned here as well. Now, when you come to the memory, the first model of Raspberry Pi came with a 256 MB RAM, and which basically was shared by the GPU. But today with Raspberry Pi version 2 and 3, you have 4 times that. You have about 1 GB of RAM, which again is shared by the GPU as well. Now the default split was at 192 MB RAM for the CPU basically, which was more than enough to play a full HD, that is a 1080p video, or perform simple 3D operations, but again not too complicated operations as well. Now moving forward, when you look at the networking capabilities, now in terms of networking capabilities, the Model A of Raspberry Pi did not have any such features, but from Model B of version 1 itself, you had an Ethernet port which was introduced here, and from version 3 you also have Wi-Fi and Bluetooth capabilities introduced here as well. Now talking about the peripherals in Raspberry Pi, there are basically 4 USB ports. Now this has been introduced in Model B version 1 plus onwards, and today you have a lot more that you can do with respect to that. Even audio input ports and audio output ports have not changed over the years, but the onboard storage has changed a lot with respect to it. Now, again, when you look at the video capabilities, video controllers, basically here you can watch complete HD videos, but Raspberry Pi does not have a H256 decoding hardware. But the CPU in itself is way more capable and helps you in decoding the H256 encoded videos through software operations. Now, in terms of GPU, the GPU in Raspberry Pi 3 runs at a higher clock frequency, which is about 300 or 400 in comparison to the previous versions, which was at about 256 megahertz. Now, in terms of video input, you have a 15-port CSI connector that has always been present with the Raspberry Pi, and video output has changed over the years. You have a HDMI port, you have a DSI port, and now you also have a 3.5 mm TRRS jack as well. Now in terms of the connector capabilities, there are 17 pins of the GPIO ports which can be configured as per your requirements as well. Now, moving forward, these are the various details with respect to the general input output pin. This data has been taken from Wikipedia. So in case if you're looking for more information, you can definitely check out Wiki's page or the official Raspberry Pi documentation as well. Now, coming down, let's begin the Raspberry Pi installation process here. Parts. First, let me help you understand the different operating systems that are available at present. Okay, Raspberry Pi in itself supports multiple operating systems as such, but we'll mainly be working on Raspbian. Okay, so these are some of the most popular operating systems supported on Raspberry Pi. So you have RIS OS, you have FreeBSD operating system, you have NetBSD operating system. Plan 9 is again from Bell Labs, as well as Windows has its own Windows 10 of IoT version. Okay, so for this session we're not going to go into the Windows 10, we'll stick to the core Raspberry Pi operating system. Now for downloading the operating system, you can go on to the original site, that is raspberrypi.org, and there in the downloads tab you can download the operating system. Let me just show it to you. Okay, so this is the Raspberry Pi home page, and here if you go on to the download section, you can download the operating system. Now if you are starting off with Raspberry Pi and Internet of Things, trust me, this is the best place that you can find a lot of information with respect to it. Okay, most people actually publish their details with respect to the projects that they're working. Many popular projects are also available. You can find a lot of help as well as good information here. Okay, so this is definitely the place to go to. If you go on to the download section here, okay, this will either show you two options. You have Noobs or you have Raspbian. I would recommend that you go with Noobs because this is a complete package with respect to the different operating systems as such. So here again you have Noobs and Noobs Lite. So my recommendation would be you download Noobs and make sure you're using a 32 GB memory card. Okay, this would be really helpful because it gives a lot of memory for your operating system. So in case if you're going for a 16 GB or below, I would recommend you go with the Noobs Lite. But make sure you keep the bare minimum of 16 GB in case if you're working with Raspberry Pi. But do not mistake me when I say use a 16 GB memory card. You can install it on an 8 GB as well. But again, the operating system has less memory to work with. So at least go for 16 or higher. 32 is what I would recommend. So once you download this zip file, or you can even download it via torrent. Okay, but I would recommend download it as a zip file. Let me show you the file. So this is the noobs file. Let me extract this. Okay, it may take some time. Okay, it's about a 1.5 GB file. Okay, the Lights version is slightly lower in comparison, but this is something that I would recommend in case if you're working with Raspberry Pi. Okay, so I have my noobs folder here. So what you need to do is that you need to copy everything inside the noob folders and then paste it inside the SD card. Okay, make sure you're not directly copy pasting the folder that you have extracted. So what happens is if you do that, it does not actually recognize the operating system as part of the Raspberry Pi. So copy everything that you have extracted and then directly paste it inside the SD card. Now again, this is why I recommend that you use a high-speed memory card, because in case if you're not using it, then what happens is that it takes a lot of time with respect to fetching the data. Okay, now as I had mentioned, if you're going for a memory card for your Raspberry Pi, you can use something like a 16 GB at least and make sure it has a high transfer speed. So this in turn will give you a lot of memory area to work around with, as well as I would recommend you take something like a class 10 memory card that is available in the market today. So these have a very good read and write speed ratio. So definitely this is something that you should consider while you're getting a memory card for your operating system. Okay, now once we're done copying with this, let's go on to install this memory card onto our Raspberry Pi and let's begin the installation process. Okay, so now we've successfully copied all that is needed for our operating system. So safely remove this, make sure you're ejecting it safely. Because sometimes what happens is if you do not safely eject it, the files get corrupted before you load it into your Raspberry Pi. This is a certain issue with respect to the memory cards. So just eject this. Okay, so this is my Raspberry Pi. And if you actually flip it over, this is the slot where you have to insert the memory card. Now we've copied the noobs folder into this memory card. Again, let me just insert this into this and let's begin with respect to the installation process. Let's begin installing this memory card onto my Raspberry Pi and start with the setup. So let me just turn on my Raspberry Pi. Okay, so this is the screen I'm getting by default. Now what happens is the installation steps initializes. So the Raspberry Pi is getting loaded. Now there are two operating systems that are present here by default, and we want Raspbian. So let me just select Raspbian and click on install option present here. Now if you see here, it basically is telling me that it requires 4.5 GB. So this is why I was recommending you to get at least 16 GB or more. Because if I have an 8 GB memory card, if 4.5 GB goes off with the operating system itself, then there's not much memory left for me to work around with. Now let me just click on install. Just before I do that, in case if you are using a different language or if you want to use a different keyboard as well, you make sure you're specifying that. Okay, so there are different languages present here, so choose the corresponding language as per your requirement. Once you selected that, just click on install, and this is just basically going to ask you whether you want to format your data and install the operating system on top of this. So click on yes, and the installation process has begun. Now it may take some time, so I request you to be a bit patient because this is an operating system installation process. So please be a bit patient and hope you have fun meanwhile. So now as you can see, the operating system installation has completed successfully. Once you hit on OK, it's going to ask me whether I want to reboot, or it would automatically reboot as well. Okay, so yeah, it's automatically rebooting at this point. Okay, now as you can see, the Raspberry Pi operating system has successfully been installed. Okay, so this is what your Raspberry Pi operating system would be looking like. Okay, so this is Raspbian as such. So there are different operating systems that are available today for you to install that we have discussed already. Now that we've installed Raspbian on our system, let's look at some of the accessories which can be used with Raspberry Pi. Now, one of the most popular and interesting accessory to Raspberry Pi is the Sense Hat. Okay, so hat basically is a hardware attached on top. There are various hats that are available, but SenseHat is the most popular because you have various onboard sensors present here. You have a temperature, humidity, and pressure sensor present here, as well as a gyroscope and a joystick also present here. Apart from this, the reason that it is quite popular is because it has an 8x8 LED matrix display that is present to it. So let me just switch over and show you the SenseHat component as well. And okay, so here you can see the SenseHat. Now how it is slightly different from the other accessories is because it's got an 8x8 LED matrix present here, which can be used for displaying various things. And we will also be seeing how you can display this as well. Now coming on to the other components here. Now if you see here, it's already got multiple sensors here. It's got an accelerometer and a gyroscope meter present here. It's also got, which is this part, the accelo and gyrometer present here. So you can see it's got labeling as well. Then you have a humidity, pressure and temperature sensor on board with respect to this, and it's quite interesting and useful as well. Now, one of the easiest things with respect to this is that it can directly be placed on top of the Raspberry Pi's GPIO pins, and thereby making it quite easy to assemble it as well. So it directly sits on top of the GPIO pins as well. So this is something which makes the entire Raspberry Pi ecosystem quite easy and effective. One other interesting key point or factor that makes the sensor quite interesting is that it's got an onboard joystick as well. So in case if you are a gamer and you want to try out the games on Raspberry Pi, you can use this joystick as such. Now, another additional component that most people use with Raspberry Pi is the camera. Now, in 2013 itself, 1 year after Raspberry Pi 1 was launched, it had introduced the Raspberry Pi camera along with the firmware update as well. Now, the Raspberry Cam is basically an 8 megapixel camera and can directly be connected to the CSI port present on the Raspberry Pi itself. Now, it's also very interesting and can record up to 1080p videos as well. So moving forward, let's also look at the infrared camera. So this is a very interesting thing. So this was something that helps you capture video in infrared mode and is called Pioneer. Okay, so again, these components can be bought online and is one of the most easily buyable. Now the final accessory and one of the most interesting and essential accessory to the Raspberry Pi is the GURD board. Now basically it is used for educational purpose and it helps you expand the operations done using the general input output pins here. So using this you can connect to various LEDs, switches, analog devices, sensors and much more. This also helps you connect to Arduino, which is also another DIY hardware device which has gained a lot of popularity, but in comparison to Raspberry Pi, Arduino is still a growing stage. Moving on, let's begin with our sensor tutorial. And what we'll be doing is we'll be exploring 5 different demos to understand how the sensat component can be used effectively. Now, the first thing that we'll be doing is we'll be implementing a very simple code, and we'll be trying to display a certain letter on top of the sensat. Okay, so I'm going to display E and D, but the value of that color is going to be generated by random. Okay, so let me just run you through the code that's present here. So the first line is from sensat import sense. So what it basically is doing is that it's helping you import sensat and establish a connection to the sensat component. We're going to use time for mainly sleep function and random for generating a random integer. Now what I'm doing is that I'm initializing the sensat, which is sense equal to sensat basically initializes it. Then what I'm doing is that I'm generating a random integer between the range of 0 to 255. Now, for those of you who would have guessed why I'm doing this, definitely this is because the RGB value lies in this range. So it's somewhere between 0 to 255. Then what I'm using is that I'm using a sensat function, which is show letter, and then I'm specifying which letter it needs to show, and I'm going to specify the color combination. So this is the RGB values present here. Okay, so it's going to show the letter E, and it's going to create a random input with respect to that same. Okay, then it's going to sleep for 1 second, again generate a new random integer, and then it is going to show D. Okay, so again it will sleep and then it's going to clear. So let me just show you this to you practically. So now what I'm going to do is that I'm going to connect to my Raspberry Pi using VNC network. So it's a virtual network which I'm connecting it to, because it's not quite easy for me to record the video on the Raspberry Pi. So I'm going to use VNC server for that. And I'll just give you a simple idea of how you can connect to VNC server to your Raspberry Pi as well. Now, one essential thing that if you are connecting to the VNC server, then you both need to be on the same network. Okay, so what I've done is that I have used a hotspot connected both my Raspberry Pi and my laptop to the same network. So in case you are wondering how to connect to your Raspberry Pi via remote server, this is how you do it. Just go to your settings, go to preferences, you have Raspberry Pi configuration here. Now in your interfaces, make sure that VNC is enabled. Once you've done this, then VNC server gets enabled, and onto your system just download VNC server and VNC viewer, and you can connect to your Raspberry Pi quite easily. Okay, so let me just show you the code which we're going to be executing. Now it's the same that we have seen earlier, so let me just make a small modification to this. So this is our code. Again, as we have seen, we are first initializing the sensat with sense equal to sensat, then we're generating a random integer, and then we're showing a letter E on that. So let me just change this. Let me just set it to 0, and let me just copy this once more, and I'll also show a third combination here as well. So I'm just generating a random value between 0 to 255, and I'm displaying based on that color letter E, D, and F. Okay, so let me just save this once. So let me show you the output that is going to be displayed on the sensat as well. So let me just execute the program. Okay, now let me just switch over to the sensat so that you can see the output. It's a red E, a green D, and a blue F as well. So this is what? So based on the inputs that I have given, it has displayed a certain letter on the sensat LED display as well. So let's go back to our presentation and look at the next program that is involved here. So the next program basically is going to display an image. Now what it does here is that it basically is going to display an image that gives you a complete idea of the various color combinations possible on the sensat as well. So what I've basically done is that I've identified the RGB colors: red, orange, yellow, green, blue, indigo, violet, and E stands for empty, which is null. Okay, and based on this I've created a random matrix here, but each of these values defines for a pixel of the sensat. Now as I have mentioned to you earlier, this is an 8 cross 8 LED matrix, so each of these values is for one of the individual pixels themselves. And with respect to how they start, the numbering starts from left top position, so accordingly it goes in a row by row manner. Okay, so let me just show you the output for this as well. So this is our program, and let me execute this and show it to you. And now let me just switch over to the Raspberry Pi. So here you can see the different color combinations that are present on the Raspberry Pi sensor. The first row was left completely empty. The next row has two R values present here. So this is how it has been defined. If you notice the code here, there are two R's following by three empty spaces. And before that also, if you can consider three empty spaces, that is one row. So every specific value is pertaining to one specific row as such. Now coming back to our presentation, so the third one is quite interesting. What we're basically going to do here is that we're going to rotate a letter based on the different orientation of the screen. So let me show you how this is done rather than just tell it to you. So what we're basically going to do here is that we're going to rotate a letter J on different angles as well. So we've defined the different angles 0, 90, 180, 270, and these are the various angles which is going to rotate for. Okay, I'm going to run a for loop where it rotates the same on different angles as well. So let me just show you that. So just let me add sense.clear here. Now the reason I'm doing that is mainly to ensure that the sensat is cleared after the rotation process. So let's execute this. Let me switch over to the Raspberry Pi, and if you see here, a J has been displayed and it's rotating. Okay, it has stopped. So let me just rerun this once again. So what is happening here is that I'm rotating the letter J by 90 degrees and it's completing two complete circles on the Raspberry Pi. Okay, so it's a very simple thing, but it's important that you understand how this is done. Because what we're basically doing is that we're setting the rotation using the sensor, okay, and then we're sleeping at 0.05 milliseconds as well. Now again, you can increase the delay here, you can change the letter here, you can even change the angle to understand how it works as well. So this is something that you should definitely explore about and get a better understanding with. Coming down, the next and most basic thing that you can do using sensor is that you can measure the temperature, pressure, and humidity. So we've already tried to do this in our previous session as well, where we've measured the temperature, the pressure, and the humidity. Now here I'm just rounding it off, and based on a specific value, I'm going to ensure whether the display is going to be red or green as well. So let me come back to my sensat. Let me just open the code and we'll modify this on the go to get a better understanding. Let me explain the code once again. So first I'm establishing a connection to the sensor, then I'm running an infinite loop where I'm getting the temperature, the pressure, the humidity, I'm rounding it off, and if the temperature is above 36, so this is just a value that I have set, then the background color should be green and the color of the text should be complete white. Okay, so this is a simple modification I have made. Else in normal situation, if it is less than 36 degrees, then what it should be is that it should have a background color of blue and the text color should be yellow. So this is basically to help me identify the different ranges. Then I'm creating a message variable which is storing the following format where temperature is equal to temperature value, pressure is equal to pressure value, and humidity is equal to the humidity value. Finally, I'm going to show this message on my Sensat LED display screen. So let's just see how this works and execute the program. So let me just execute the program and let me also switch over to the Raspberry Pi. So here let's begin with the execution of the code. So now you can see by default it is having a blue background and the text is actually in yellow. Okay, so if you would have noticed, the temperature is about 34 degrees centigrade. So to this, let it scroll once more. Let's just validate the value of temperature. You can also print this into the screen. You can also send it via an API and much more. So if you can see, it's 34.2 degrees centigrade. Now to this, what I'm going to do basically is that I'm just going to introduce a hot water source. Okay, so I'm just trying to raise the temperature here. So let me just shift it a little bit and please keep a note on the temperature value. So the temperature has started rising. So it is taking some time. I think the water has cooled down a bit. Alright, so it's started. Now the color, background color has changed from blue to green, and the text color has changed from yellow to white as well. Now these can be used in critical measure environments as well. So let's say you are in a situation or an environment where you need to have a constant monitor and constantly be aware with respect to the environment change. In example like space or any other environment that you're working with, definitely these are certain things that can really be important and helpful as well. So coming back, let's just look at the last program of the Sensat tutorial, which is basically detecting the motion of the Sensat. Now, what I'm basically going to do here is that I'm going to rotate my Sensat and I'm going to identify the value of pitch, roll, and yaw. Basically, these are the orientation with respect to the x-axis, y-axis, and z-axis, and this is just from the orientation of the Sensat as well. Now, this is mainly done using the gyroscope, but to get a better understanding and more precise value, we'll also try to include and incorporate the accelerometer as well. So let me come here. Let me just show you the program. So this is the program as well. So let me just stop the execution here. So as I had mentioned, this is going to run infinite number of times because the while statement here is indefinite. So let me just stop this and let me just run the orientation program. And let's just see the default values of pitch, yaw, and roll first. So now by default, if you see, pitch is about 0, roll is about 96, and yaw is about 0 itself. Now let me just switch over to the Sensat, and what I'm going to do parallelly is that let me try variating the value of the Sensat as well. Or let me try rotating the Sensat to give you a better understanding of how it works. Simultaneously, you can also see the change in pitch, yaw, and roll. So if you see here, I'm slightly lifting it and the value of pitch has risen from 0 to 6. Roll also has changed. Yawn also has changed. I'm going to try tilting it. Same pitch, roll, and yawn also has changed. So I'm just tilting it with respect to various axes and you can see the change here. Do you notice the changes? I definitely hope you do. Okay, so now let us actually stop the execution of this program because this is also an infinite loop, and to same orientation program, let us actually try to incorporate the accelerometer and understand how more precise we can make. Now instead of just taking the pitch, roll, and yawn, I'm here going to directly take the value of acceleration. Here we had taken the value of orientation, and here we're going to take the value of acceleration. Okay, how basically it differs is with respect to the gravitational force that acts on this. So now let me just show you the code here. Now again, what you need to understand, the difference between gyro measure and accelerometer is just that it senses both the static as well as dynamic change with respect to that, but your gyroscope mainly measures the rotation of a specific device as such. Okay, so let me just execute this program as well. So let me just first begin by clearing the screen, and then we'll execute the code once again. So let's just execute the acceleration code to get a better understanding. And simultaneously, what I'll do is that I'll just show you how the change with respect to the axes, or how you, if you change the Raspberry Pi, how the value will also change. So by default, if you can see, the value of X is 0, the value of Y is also 0, and Z is 1. So now what I'm going to do is that let me begin by slightly rotating the Raspberry Pi. Now, if I change the Raspberry Pi into a vertical position like this, okay, so it's a perfectly vertical position. But if you notice the value of X, it has become -1. Okay, Y has become 0 and Z has become 0. Same time, if I rotate it in such a manner, I'm just keeping it on different axis. The value of X becomes +1 instead of -1. Same with respect to Y. If I change it in such a horizontal way, it is -1, and if I change it in such a manner, then it becomes +1. Okay. Now, if you flip it completely over, then the value of Z becomes -1 as well. So if this is the vertical position, then the value of Z remains 1. I hope this is clear for you guys. So again, these are all different parameters. Today, what I have done as part of this is that I've just helped you understand how you can explore the various parameters and various components that are associated to the Raspberry Pi Sensat as well. Now, how you use it and what you use it for is completely left to you. These are just some of the basic things that you can do using Raspberry Pi. The limitation of Raspberry Pi stops where your imagination stops. Now moving forward, let's look at the most important part and the interesting part of today's session, which is basically the demo using Raspberry Pi. So what we're going to do here is that we're going to try to create a motion detection system. So we're going to build a security camera system which detects the motion in front of it and it captures an image based on this. So how it does is that first you're going to store an initial frame. So this is going to be my reference. So here image is going to get converted to Gaussian blur image. So this is going to be a grayscale image actually, and going to get converted to Gaussian blur. And simultaneously it's going to take a frame with object. Once the initial frame is set, then what it's going to do is that it's going to take the frame with any changes and then it's going to convert it to Gaussian blur image. So this is going to be my reference. So once I do that, then I'm going to take the difference between the initial frame and the converted Gaussian blur image, and if there is a difference detected, I'm going to save this image. If not, I'm just going to keep checking for any change with respect to that. So let me just show you the code here. Now for this we're going to use Android IPCam web application. Okay, so this can be downloaded from the Google Store. Let me just show you. So this is the application that we're going to be using for this demo. It's IP webcam. So you can check it out on the Play Store and I'll show you how you can identify and connect with this. So let me come back here. So here what you're going to do, this is the program that we're going to use for motion detection. Now, firstly, you're going to use import user lib. This is basically to connect to the Android device. Now, like I had mentioned, if you want to know the IP address, just launch the application, click on start server, and you'll be seeing the IP4 address, which I have specified here. Okay, then you're going to use CV2 and time, which is most important libraries as part of it. CV2 is what we're going to use for the image processing. And I'm also using NumPy. So all the images that we're going to be storing are going to be processed by NumPy. This is basically to help us create a pixel image with respect to the initial image taken. Now I have specified the URL of my IPCam, and what I'm doing here is that I'm connecting to that. Then what I'm going to do is that I'm going to convert it to a NumPy array and then begin my cv2.image decode. So I'm going to begin the decoding. So this is just for your reference. You can also remove this and it will still work the same. Okay, now what I've done here is that I've initialized my value of I to be 0. Now this is something that is quite interesting and important to remember. Then I'm going to run an infinite while loop. Now here I'm just doing the same thing. I'm just connecting to my IPCam. I'm going to take the image into a NumPy format and I'm going to decode it. And then what I'm going to do is that I'm going to convert the initial color image to grayscale. Now before I create a Gaussian blur, I need to create a grayscale image. So that's why I'm going to first convert the color image to a gray image. Then what I'm going to do is that I'm going to create a Gaussian blur image wherein I'm going to specify the grayscale image. Then 2121 is basically the frame size and 0 is just a parameter. Then what I'm going to see is that I'm going to first check if there is a first frame defined. If there isn't, then the Gaussian blur image is going to become my first frame, and then I'm going to go back into the loop to take the next image. If not, then I'm going to execute the following code. Now, once I have identified this, then what I'm going to do is that I'm going to find the difference between the same. Okay, so if I have not defined the first frame, then I'll assign the grayscale image I have just taken as the first image. If not, then what I'll do is that I'll identify the difference between the first frame and the grayscale image that I have taken. Then what I'll do is that I'll define a threshold here. Now, the idea of defining a threshold is that if an object does not occupy a minimum of 30 pixels, okay, then it's not worth capturing in camera. So what I'm telling is that if it is less than 30 pixels, then make it white. That's what this function does here. Okay, so if it is less than 30 pixels, ignore it and change it to white color. Okay, and then what I'm going to do is that I'm going to dilate the image using the cv2.dilate, and what I'm doing here is that I'm just making the image a slightly more sharper and precise image with respect to that. Now the function cv2.findContours, what it does basically is that it helps you make your image sharper. Basically it creates a curve that joins all the continuous points or the boundaries and make it a sharper image with respect to that same. So I've dilated the image, now I need to sharpen it with respect to that. And then what is happening is that it's going to show me the frame of the image as well. So I'm just going to define a condition where if it is less than 1 lakh, then I am not going to take the picture. But if it is, then I'm going to define a boundary Okay, and then I'm going to capture it with respect to an image. Okay, so let me just run this, and first let's establish the first frame, and it will show me the frame as well. Okay, so the first frame is getting initialized here. Let's just have a look at the first frame. All right, so what it is doing at this moment is that it's actually initializing the first frame so that it can have a reference with respect to that same. Okay, so I have a friend who's just opening the door and we're trying to capture the detection from that. And let's just see how this has had. Now we've defined Q to exit from this frame. So let's just come back to this and let me just try to close it. Okay, this certain times does happen that it gets stuck because sometimes what happens is the reference frame slightly becomes different. But let's just look at the images and it has started capturing the images. Okay, so let me just show you a simple idea of how it has captured the images. Okay, so as you can see, it has captured all the motion that was beyond the frame as well. And it has also created a frame in respect to the motion wherever it has detected. So this can be further modified for any future references wherein you can also improve this for a face detection system and so forth as well. So let's go back, and with this, let's come to a conclusion of this session. Hope you had a great learning experience. Thank you and goodbye.